just want to talk very quickly about the sine graph before we get into this transformed version of it. So sine graph looks a bit like this. Now, a line of symmetry actually is any line where it looks the same to the right as it does to the left. So for example, this red line going through the first peak would be a line of symmetry. Then it looks exactly the same either side. But actually, so would this bottom line, and so would this one. So in fact, the line of symmetry on any sine or cos graph is, a line of symmetry on any sine or cos graph is any line that goes through a peak or a trough. So in fact, to solve this, you could solve this equal to plus or minus 1. And then solve it in the first case and the second case and find the smallest value of x. That will work absolutely fine. I've seen that in work solutions. I'm going to go for it in a slightly different way. Because I think it's actually quite nice to just look at the original graph. Except I'm now going to look at sine 2x. If I find some lines of symmetry for sine 2x and then think about the transformation, so I'm doing the stretch first and I'm going to do a translation. This will actually get me the result really quickly. This is how I did it, but by all means go with that approach. So for sine 2x, right, normally it goes 0 to pi, but this is going to be pi over 2. Actually, this is going to be pi over 4. That's going to be my first line of symmetry for sine 2x, or first positive one. And then I'd get 3 pi over 4, and so on. Now, there would be some afterwards, sorry, to the left, so I should probably look at them, especially because you can see with the translation I'm going to be adding on a value. I'm not going to say 4 pi over 3 yet because it's actually not. So here, I would then get, okay, let me just continue that. That would be minus pi over 2. So then I would get minus pi over 4. And then here, I'd get minus 3 pi over 4. Right, so I've actually worked out different lines of symmetry for sine 2x. Just going to circle them. And I can see I'm adding something on. So actually these ones are really the ones I'm interested in. So let's look at sine 2x minus 4 pi over 3. Now this is in fact not a translation by 4 pi over 3 of sine 2x. Be really careful because when you apply the transformation, you would replace x by, so if I actually took sine 2x and wanted to do a translation by 4 pi over 3, I would actually replace x by x minus 4 pi over 3. So you can see when I times through by 2, I wouldn't then get the same thing. So what I'm saying we have to do instead is factorize out the 2, and it'll be x minus 2 pi over 3. So if I want to do the stretch first, this is covered in more detail in the second year about successive transformations, so that's why it might be better to talk about this approach. It's just you just end up solving a load of equations, and so if you do know your successive transformations, I think this approach is really good. But yeah, if you want to do the stretch first, you then have to do a translation by 2 pi over 3. So all I need to do now, if I recognize that, is to take each of the lines of symmetry, so minus 3 pi over 4, and then I'm just going to add on 2 pi over 3. That will give me my new line of symmetry. Now actually, 2/3 is less than 3/4. This is going to be less than 0. I don't even need to work out what it is. So it's going to be that minus pi over 4 that's going to work and give me my first line of symmetry that has a positive value of a. So I can put them over a common denominator. It's going to be minus 3 pi over 12 plus 8 pi over 12. X is then going to equal 5 pi over 12. That is our answer. So if you were to solve it equal to 1 and minus 1, you would get that as one of your solutions, and it would be the smallest positive one essentially. So again, like I said, have a look at that if you prefer that route, but this route works really well. You can get your head around the transformations.